Yes, good evening to all of you. So, in the last class, we had defined a few things, just to recall those things. So, both the cases, f is a map from x to y. If x is a map from x to y, right? So, obviously, x is non-empty, y is non-empty, and all that you know. So f is 1, 1, right? When is f is 1, 1, right? We have two types of definitions, definition 1 and definition 2, right? What is the definition 1? Given any x1 comma x2 belongs to x, given any x1 x2 in x, okay, f of x1, if f of x1 is equal to f of x2, if f of x1 is equal to f of x2, then x1 is equal to x2, right? This is one definition. What is the other definition? So given any x1 comma x2 in x, okay, given x1 comma x2 in x, if x1 not equal to x2, then f of x1 not equal to f of x2. Okay, so it is better that this you remember, but the reason is that it tells that distinct elements map to distinct elements. Okay, it is also same thing. If the images are same, then elements has to be same. Images are different, the pre-images also different. Both are same, but this is conveys that distinct elements map to distinct images, right? Distinct elements, right? Why these two are equivalent? So these two are equivalent because of the contrapositive. The contrapositive of this is this, and right, yeah, they are contrapositive to each other. That's why these two definitions are same. What is the meaning that they are equivalent? When you can use either of the definitions, when sometimes this can be proved easily, sometimes this can be proved easily. For example, I want to show f is a map from R to R. Okay, okay. Then so is it f of x equal to x cube? Is it 1 1? Is it 1 1? Is f of x equal to x cube is 1 1, right? In that case, this will be little easy. Of course, both can we can one can do in both. Is f x cube is 1 1. So if you start x1 not equal to x2, okay, let us say a not equal to b, right? A not equal to b. So we want to show that f of a not equal to f of b, right? Okay, so this is the statement I want to show. So I will take negation of s. Negation of s is f of a is equal to f of b, right? This implies a cube is equal to b cube. Okay, this implies a minus b into a square plus ab plus b square is equal to 0, right? Okay, so now we can easily show that since a not equal to b I started, right? Then product of two real numbers equal to 0, one of them has to be 0. Now you can show that this is not equal to 0, right? We can easily show that. So there is a, this is false, right? Then that can be true. Yeah, okay. Am I clear about this? Can you tick yes if you are clear? Okay, good. What do you mean by function is not 1 1? Not 1 1 means f is, you always need to ask these questions, okay? Once definition is came, what do you mean by not 1, not negation of that? Not 1 1 means there exist, right? In the definition, given any x1, x2, x1 not equal to x2, f of x1 not equal to x2, right? Not 1 1 means there exist two numbers, x1 and x2, right? Not equal, right? But f of x1 is equal to f of x2, right? Then it is not 1 1, right? There exist two elements. They are not equal, their images are equal. It is not 1, right? Easy to clear. Okay. Okay. So I hope all of you are clear with. Now we'll go to the other thing. So f is onto. When we say that f is onto, right? So again, there are two definitions you told yesterday. Definition one is that given any y in y, So y is the codomain. There exists x in x such that f of x equal to y. Or y is equal to f of x is better. Okay. Right? Y is equal to f of x. What is the definition 2? Definition 2, you told that, one of you told that range of f is equal to y. That is same as this. Y belongs to y means y belong to range of f. Y belong to range of f means there exists an x such that y is equal to f of x, right? What do you mean by not onto, right? We need to ask those questions. F is not onto, right? So this is my S, right? Statement. What is the negation of this? Okay. So given any y, something is true. Onto means given any y in y, something is true. There is an x. Y has a pre-image, right? So that is not true means there exists a y, right? That does not have a pre-image, right? So if someone want to tell what is mean by f is not onto, if you're ready, can you tick yes? Be quick. F is onto meaning this part, not onto means what? So how do you do this? Let us see how do you tell. Shivam Kumar.
There exists y belongs to y for which x not exist belonging to x.
Not exist means what?
Y
That is the
doesn't equal to fx.
no, no, not exist means what? I do not know that. This is not the way to tell. Not exist does not, okay? That is not. So see, this is try to understand. So this is onto mean given any y, this is true. Not onto means there is a y, this is not true. Okay, now look, concentrate inside. What do you mean by this is not true? Okay, there exists a x. What do you mean by that? This is not true means what? This is not correct.
There exists x not belonging to x.
No. Okay, Pujita.
So given any x belonging to x,
Given any x belongs to x,
y is not equal to f of x.
y is not equal to f of x. Okay, whatever x you give me, y is not equal to f of x. Not onto means what? There is an element that does not have a pre-image. That means whatever x you give me, y is not equal to f of x. Right? This is very crucial. Again, you got an opportunity to understand that how to negate things, how to use the quantifiers. You understand the beauty that what it is conveying, lot of things it is conveying, right? Not onto means there is an element in the codomain. Whatever x you give me, y is not equal to f of x. That means y does not have a pre-image. Are you clear with Shivam now at least?
Yes, sir.
Yeah, so you need to be tell this way. Okay. This conveys a lot. Yeah, okay. We also told actually, is there any student in this room from Manipur? No student is this Manipur. Also correct, but we told that do not say like that. Given any student in this class, he is not he is not from Manipur. He or she not from Manipur. Okay, that will better advantage for us to negate or like that. Okay. Okay, fine, good. Now get back to the things. Okay, I'm giving some examples. So let us see, right? So for example, I have a map, okay? G32, okay? January, February, like that, okay? Up to December, right? So G3 to the months, okay? Hope it is clear to you what I'm writing. Somebody can give a map. Somebody can give a map if you are okay. G3 to the months, January, February, December, like that. Do you have some map? Kajal, what is that you are thinking? X map
Sir,
to
birthday month, sir.
month, right? Yes, month, the
Of
birth
birthday.
month. Yeah, birth month.
Yes.
Birth month of X. Good, correct. Okay. So I am telling that F is not onto. What is the meaning of that? F is not onto. What is the meaning of that? If someone can point out
Day.
that, I'm clearing now. No, not you, not you. So I'm clearing now. So wait, all of you wait once, wait. We are clearing the feedback. Now you can click. Now you can click. Is anyone want to comment on this? What do you mean by F is not onto? What do you mean by F is not onto? F is a map from G3 to the student months of the students born, right? Okay. Reenu,
Yes, sir.
what do you mean by F is not onto?
We take an element from codomain like
Mhm.
December.
Okay.
If
Yeah,
if any
you are,
stu- if any
you are,
students
uh,
its birthday is not December, तभी सर
uh,
इसकी प्रीमेज नहीं मिलेगी. इसको on to
okay. That means there is a month.
सर
आप अंग्रेजी में बताओ, अंग्रेजी नहीं तो हिंदी में बताओ. इसका मतलब क्या है? नॉट ऑन का मतलब आप आराम से मैथमेटिक्स का छोड़ दो, किसी की हिंदी की लैंग्वेज में बता सकते हो. बताओ आपका, आप क्या सोच रहे हैं? आपने ठीक सोच रहे हैं.
सर कोडोमेन से दिसंबर मंथ लेंगे.
हाँ, ओके, ठीक है.
फिर इसकी प्रीमेज देखेंगे. अगर प्रीमेज नहीं मिली तो ये ऑन टू फंक्शन नहीं है.
उसका मतलब क्या है? उसका मतलब क्या है? किसी भी स्टूडेंट ले लो G3 से.
हाँ,
वो
अगर उसका बर्थडे दिसंबर में नहीं है
हाँ, उसका मतलब क्या है? दिसंबर में
और
किसी
कोई भी
स्टूडेंट
स्टूडेंट्स का बर्थडे दिसंबर में नहीं है.
नहीं है, राइट? दैट इज द व्हाट. या ओके. So that understood. Okay, it is on to means what?
ऑन टू
Sujit,
का
Sujit, ये on to मतलब क्या है? इस फंक्शन on to मतलब क्या है?
For sir, for all y belongs to months of birthday, there
हाँ,
exists x belongs to G3,
हाँ,
y equal to fx.
that means that you take any month first, right? On to
Yeah,
में
yes,
आपने
sir.
क्या देखते हैं? Wonderful, you told very nicely. All of you listen carefully what Sujit told. You need to concentrate on the codomain, not the domain. When you're talking about onto, किसी भी मंथ ले लो, उस मंथ में किसी ना किसी एक स्टूडेंट है, उस मंथ में बोर्न हुआ है. एवरी मंथ हैज ए प्री इमेज. दैट मीन्स किसी भी मंथ ले लो, उनका एक प्री इमेज मिलेगा. ओके, गुड, नाइस. ओके, नाउ so now I'm giving few more questions, right? Okay, like that, create more questions. Students to room numbers 1 to 11 ले लो. Okay, is it on to or not? Ask questions yourself. Okay, now I'm going to other example. So I'm taking n cross n to n. Okay, my function is from n cross n to n. Okay, my map is that a comma b mapped to, okay, a comma b mapped to a only, right? A comma b mapped to a only, right? So also think about what do you mean by n cross n, right? What do you mean by n cross n? Correct. So this is my one. So this is okay. This point is 1 comma 1. Hope you are understanding. This point is 2 comma 2, right? This point is x value 1 and y value 2, right? Yeah, like that, right? So all are natural numbers only. Okay, na? All are natural numbers only, right? Yeah, like that we are taking, right? Yeah, so it will continue like that. Okay, so and these are mapped to again natural numbers. Here 1, here 2, right? This is a domain, and this is codomain, right? This is codomain. Okay, you need to visualize also, then only you will understand better. Okay, where I'm mapping to, where 1 comma 1 mapped to, like that you ask, where 1 comma 1 mapped to, right? Yeah. Okay, my question is that, is it on to? Is anyone want to comment? Be quick. Is it on to or not? This function n cross a comma b mapped to a. Is it on to or not? onto, not 1 1 I am saying. Okay, think, listen carefully. Is it onto or not? Onto मतलब क्या देखना है? नेचुरल नंबर में दो कोडोमाइन में एक नंबर ले लो, किसी का नंबर. ओके, आपका मन में क्या आ रहे हैं? आप मुझको तो 8 आता है, क्योंकि मैं डेट ऑफ बर्थ आज 8 है, राइट? 8 का प्रीमेज है या नहीं मैं देखता हूँ, राइट? एग्जाम्पल, राइट? या बट वेरी लेस. वाई आर यू फेसिंग डिफिकल्टी हियर दिस फंक्शन पे? 2, 3 के मैप कहाँ हो रहे हैं, ऐसा आप पूछते तो आपको समझ में आएगा फंक्शन क्या है. लेकिन वेरी नंबर ऑफ रेस्पॉन्सेस आर वेरी वेरी लेस. इज इट ऑन टू आर नॉट, राइट? दैट इज द क्वेश्चन वी आर आस्किंग, राइट? Yushika Gupta. Hello, Yushika.
Yes, sir.
What is that? On to
Sir,
or not?
yes, sir. On to.
Okay. Can you tell me 100 का प्री इमेज बताओ एक. 100.
100,0. Sorry, 100,1.
100,1. Okay. कितनी प्री इमेजेस है?
Infinite.
Infinite. Okay. Can you tell me few?
100,2, 100,3, and so
Very,
on.
very. Yeah, good, good, nice. Okay. Yeah, Yuvraj, I think is it clear to you? Yuvraj.
Yes, sir.
Okay, okay. Thank you, Yuvraj. Yeah. Okay, good, nice. Okay, this is on to function. Is it 1 1? Is it 1 1? Okay, I'm clearing now. All of you clear because she already told. Is it 1 1 function? Is it 1 1? 1 1 meaning distinct elements map to distinct, right? Is it 1 1? Okay, Aina? Shelly Sharma, sorry. Shelly Sharma, room number 3.
No, sir, it is not 1 1.
1 1 मतलब आपको एग्जाम्पल तो देना पड़ेगा.
जी हाँ जी सर, जैसे we can
Hmm.
find, अगर हम 100 का देखें, we can find pre-images in 100,1, 100,2.
Very good. F of 100,1, F of 100,2, दोनों का
But
इमेज है 100 only, but these 2 points 100,1 is not equal to 100,2. Why these 2 points are not equal? Because 2 points are equal means A comma B is equal to C comma D. मतलब क्या है? A equal
A
to
is
C
equals
होना है.
to C and B equals to D.
Correct. So लेकिन यहाँ why 1 is not equal to, so this is not. Okay, good, correct. Okay, clear. Yeah, yes, I hope you are clear with the answer. Yeah, this is 1 1 2, right? Yeah. Okay. What about this map? F of A comma B, I am taking, now I am defining a new map, right? A plus B now. Okay. F of A comma B equal to A plus B. No, I will not ask questions. You ask 1 1 and 2. If you want to comment, comment. Again, it is a map from n cross n to n. Is it 1 1 or not? Is it 1 1 or not? On to or not? So let me know. You want to comment? I am not told. No need to tick yes or no here. This is, do you want to comment? Comment and tick yes. There is no need to tick no here. No meaning I do not want to speak, right? I do not want to comment. That is okay. That is also for that you can take. Kathy, room number 8, it seems. Kathy?
Yes, sir. It is on 2 because we can find the pre-image, but it is not 1 1 because if we take an example of 5, 5 can be written as 1 plus 4 and 4 plus 1, but these are not equal.
Okay. Okay. So we'll go slowly. You told that it is on
How
to,
many
but not
agree with her answer? You can ask.
Yeah, I'll ask that. Yeah, I'll ask. Yeah, so I'll ask that. So all of you now what she told, okay? She told that it is on to but not 1 1. But first 1 1, what is the response she gave? 5, 1 comma 4 and 2 comma 3.
1 or 2.
4 comma 1,
Yes.
2 comma 3. F of 2 comma 3 and F of 4 comma 1 both are mapped to equal to 5. But now 1 comma 4 is not equal to 2 comma 3. That's what she is saying. But she told onto, right? How many of you agree that it is onto with her? How many of you agree with onto? How many of you agree with her onto? Okay, Kathy, 100 का प्री इमेज क्या है?
Sir, 100 का pre image
Pre
can be 9,
pre image
98, comma 2,
9
1,
9 yeah
99, comma
98
1,
comma
1, comma
2, right?
99.
आप भी there are many people are saying that it is not onto. आप सोच सकते हो कि किसी के नंबर को कोई प्री इमेज नहीं है, ऐसा आप देख सकते हो. बहुत लोग बोल रहे हैं नॉट ट्रू. क्या करें? आपको कोई
Example
समझ
देना
में आ रहा
पड़ेगा.
है? मेजॉरिटी पीपल आर
Sir,
सेइंग नो.
1,
हाँ
1, 1.
या 1 का प्री इमेज नहीं है. मुझको पता है आप
नहीं है.
बताएंगे, की वजह से मैं वेट कर रहा हूँ. ठीक है, 1 का प्री इमेज नहीं है. क्यों? Because what is the, if you take any n cross n पे 1 comma 1 is there. That is the thing only give the smallest sum, right? 1 comma 1 only the number which will give the smallest sum. That itself is 2, right? 1 does not have a pre-image. You see the beauty of this example. Why you got confusion? Almost every element has a pre-image, but one element does not have. Even one element does not have, that is not onto, right? Yeah.
Yes.
Similarly, so please ask questions like this. For example, if I have a map, right? So for example, I'll take a map like this, right? N to n, right? So I'll give a map f of x equal to x plus 1, right? So check whether it is 1, 1 or not, onto or not. Okay, all of you. I'm not asking you now, okay? You can create more examples, right? Okay, so let us go further. But here I will give few more problems for you. So I'm taking that f of a comma b is equal to 2 power a 3 power b. Okay, my function is f of a comma b equal 2 power a into 3 power b. So is it 1 1 or not? Is f 1 1? Is f on 2? These are the questions to you. Okay, are you clear? Questions are clear. Can you take guess? Just questions. Questions are clear. I'm not asking you. It takes time to check, right? Is f 1 1? Is f on 2? Okay, these are the questions. Okay. Again, the map is from n cross n to n only. Okay, na? N cross n to n. N cross n to n, right? This question, that is a little different earlier one, right? This part. Yeah. Somebody raised hand, no raise hand. Okay. You have a doubt that what is the domain, right? Yeah. Now I written clearly. N cross n to n. Okay. Suppose Manlo it is 1 1. Manlo it is 1 1. Then what is the range of f? What is the connection between range of f and natural numbers? Suppose I'm writing suppose f is 1 1. Okay. You know इसका continuation यहाँ पर आएगा ना, दूसरी पेज पे आ गया. Okay. F is 1 1, right? Then what about the range of f, right? So that means range of f means f of n cross n, right? F of n cross n. Okay. So and n का connection क्या है? You know that range of f and the n is the codomain, right? And if it is 1 1, so what do you think, right? If it is 1 1, then almost this cardinality, okay, number of elements in n cross n, and yeah, it is quite interesting, right? This is a subset, and its cardinalities I'm not telling. I just come back to that later. Just giving without. So almost this cardinality is almost n cross n because it is 1 1. I will come back. Okay, I'll explain you much better way later. Why I'm telling this is that n cross n looks bigger, but it is contained in natural numbers under this, right? So that is what Cantor done. Many people thought that he has a pagal आदमी है, उनको SLM में डाल दिया, right? Later after his death, people came to know that he is correct. Okay, some sets are looks bigger, but actually they are number of elements going to be same. Okay, I'll explain that in a while. Yeah. Okay. But I don't know whether it is 1 1 or not. If it is 1 1, this is the thing. You need to check that. Okay. Yeah. Any questions you want to ask me? I'm not asking the answer to this, right? That you can think about. Do you have any questions? I'm clearing your feedback. Yeah. So do you have any questions? Okay. No questions. Then I'll ask another question now to you. So F is a map from R to R. Okay. So X is map and alpha is some real number. If alpha belongs to real number, fixed. Okay. Alpha belongs. So X mapped to alpha X, alpha times X. Okay. X mapped to alpha times X. So somebody can tell me, is it 1 1 on 2 or whatever you want to comment, you can comment. Open to you. Problem is open to you. Alpha belongs to R is fixed. Okay. This is fixed. So once I fix that is there. For example, alpha is 2, then X goes to 2X. If it is 3, 3X. So we can also call F alpha if you want. Okay. F alpha of X is equal to alpha times X. Now, this is the function F alpha total milake function. Right. Yeah. Is anyone want to comment? Any comment you want to make? Whatever you feel. So since it is open, you can say something, right? Okay. Shivali, I'm not talking to you till now. Shivani, रूम नंबर 9. आप कुछ बताना चाह रहे हो? बताओ. Shivani, room number 9. Okay. You are not unmuting. Okay. I'll ask other person. Right. Okay. Avani Jain, आप कुछ बताना चाह रहे हैं?
Yes, sir. I think it will be 1 1 because for every element there will be a single preimage.
Okay. 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 Is it on to also?
Yes, sir.
Okay. You are telling it is 1 1 and on to also. Okay. I will check with other person, right? Teja Soda.
Sir, if alpha is 0, then
Avani,
it's a constant
Avani,
function, then it's not
what
1
is that
1.
you comment? Yeah. Avani, are you listening to him?
Yes, sir. Now I got it.
हाँ
In
नो
this
अल्फा
case,
इक्वल टू 0 होते तो क्या होगा? उसके बारे में बताओ कुछ. देन ओके ओके गलत हुआ
sir,
है लेकिन अभी हाँ
sir, if alpha will be 0, in that case, for any x which we are taking from real numbers, its image will be 0 only. Even if I take
हाँ
1, 2, 3, 4,
no
so
no
all
that's
will
okay.
have image
From that
0.
what you conclude? From that what you conclude? Yeah, that's
That
what I'm saying.
codomain is not equal to range, so it is
That is
not
okay,
onto.
ma'am. That is okay. If alpha equal to 0, what we can say about this function of alpha?
It is not onto.
Not onto is okay. You can tell much better. Okay. Yeah. Om, can you say something? If alpha equal to 0, what we can say about f alpha? She told that whatever element you take, it mapped to 0, right? What we can say about this?
So it won't be 1 1.
Not 1 1 is fine. Not onto also fine. वो समझ गया. और ज़्यादा बता सकते हो इसके बारे में. That is my favorite. Every day I'm saying that.
It is a constant function.
Yeah, constant function है ना? Yeah. It is everything mapped to 0, right? Everything mapped to 0. Okay. Since you are telling that, so I will ask these questions to you. Okay. But discussions are sometime later. Okay. F is constant. F is constant and 1 1 also. Okay. F is constant and 1 when it happens, right? So can you see some if and
When
only function? No, not you, not for you. Okay. In general, F is 1 1 and constant if and only if. Okay. Similarly, F is constant and onto. F is constant and onto, right? And onto and okay. Then what we can say, right? If and only if. So these are interesting. Like that, you need to ask several questions, right? If and only, right? Okay. Okay. So constant function to aa gaya. Is there any person can tell that can I get identity function also for some value? Unmute and say, no problem.
For alpha is equal to 1.
Alpha is equal to 1 if you take, you will get an identity function also. Okay. And you can easily check that this is both 1, 1 and onto when alpha not equal to 0. In all other cases, as Avani told what Avani told is correct. Only one case is missing, that is 0. That is the thing. Always 0 and this 0 creates some problems. Okay. So Indians invented, but it's creates some problem, right? Yeah, sometimes. Yeah. Okay, good. Okay, so happy, but be complete it. How to prove it is 1, 1, how to prove it is onto. You need to prove it. Okay. To prove it is 1, 1, f of a equal to f of b. What is the meaning? Okay, alpha not equal to 0, we are assuming. Okay, alpha not equal to 0. How do you show it is 1, 1? F of a equal to f of b. What is the meaning? Alpha times a equal to alpha times b. What is the meaning? Alpha times a minus b equal to 0. Now you know alpha not equal to 0. Like that, you need to discuss. Similarly, next thing, why it is onto means what? Okay, f of f. So onto means what? Okay, I take y belongs to real number again, right? So what is its pre-image? Okay, okay, alpha not equal to 0. Yeah, is anyone want to comment that? Can you go in and can you clear? Is anyone want to comment? Comment on that. So you are telling when alpha not equal to 0, it is onto also, right? Onto matlab, I take an element y in codomain, right? Then you need to produce an element in the domain such that that element mapped to y. The function is, so the definition is that f of a equal to alpha times a, right? This is the definition we have, right? Now I do not know what is this. Now this you need to tell, right? For example, if I say 100, what is that I had to take here? If it is pi, what is that I had to take? Like that, you need to ask questions. Onto is not easy, okay? You are thinking you understood. No. Okay. Nandini Gupta, room number 9.
Yes, sir. The pre-image would be y by alpha.
Y by alpha. Wonderful. Why y by alpha exist? Is it y by alpha belongs to real number?
Yes, sir. Because alpha is not equal to 0 and
Right. Yes, yes, yes. You told actually. Good. Okay. Are you understanding? Right. Alpha not equal to 0. So y by alpha exists and it is in the code domain, right? And f of y by alpha equal to alpha times y by alpha. Like that we need to ask. Okay. So all of you. So I hope you are understood till now these examples. Now we will move forward, right? I'm going to have a new concept now onwards, right? Some new concept. So this is the last definition of this course, right? F is a map from X to Y, right? I'm taking a C subset of Y. Earlier you remember last class में हमने यहाँ subset लिया, ये A subset of X or B subset of X. F of A के बारे में पूछा, right? Now we are talking about another thing, F inverse of C, okay? Please be careful. Be careful. Okay, I told you that so bad luck. Okay, we have the same notation for two things, right? Yeah. So please try to understand, be careful. What is a be careful? So here entire thing matters. Entire thing matters. I'll tell you what is that mean. Entire thing matters. F inverse itself does not matter. No meaning. Itself no meaning. Itself no meaning. Okay. Meaning only when F is in bijective. Okay. Has meaning. If time permits, I will tell you that also has meaning only when F is invertible. Okay. So in mathematics, this is the one place that notation is creating a confusion. Okay. A notation confusion. Okay. Notation and confusion. Just I am writing like that. So people, so this is not F inverse. F inverse of something. No. पूरा मिला के ये एक ऑब्जेक्ट है, इनका डेफिनेशन है. ओके, व्हाट इज एफ इनवर्स ऑफ सी? सी इज अ सबसेट ऑफ वाई. एफ इनवर्स ऑफ टी definition is f inverse of c F inverse of C पूरा मिला के इनका definition है. Definition generally you put 2 dots. Okay. So these are the elements of. So it is a subset of X. Okay. I am defining it clearly. Okay. This is subset of X now. Okay. So functions are very democratic. Earlier here I gave a subset. F of A is a subset here. Now I am giving a subset Y. I am giving a subset for X now. How it is defined? X belongs to X such that such that f of x belongs to C. Such that f of x belongs to C. Because x is in x, f of x is in y, right? But which x I am collecting? Those y's which are in C. Okay. So what is the diagram for this? So what is diagrammatically, what is this? Okay, let me move forward. Okay. So diagrammatically, what is the meaning of this? So I'm taking, so I have x here, I have y here, right? I have x here, I have y here, and I have some C here, right? So I am looking those elements here which are mapped to C. Okay. So I am collecting. This quantity is called F inverse of C. Okay. F inverse of C. It is a set first. Subset of X. Subset of X. Which elements it contains? Those X such that F of X belongs to C. Why I am telling all these things? Definitions are very crucial. आपको समझ में आ रहे हैं? हम बहुत दिन से हम यही कर रहे हैं. Definition समझने के लिए examples दे रहे हैं, counter examples दे रहे हैं, right? So once you are clear with the definition, mathematics becomes easy. Okay. Yeah. Okay. So good. So now one particular case is that this is a subset. Okay. I take a small y belongs to y. Then I can take a singleton set. It is subset of y, right? Then I can talk about F inverse of y, right? So F inverse of singleton y, right? F inverse of singleton y, right? Yeah. Somebody can tell me what is the definition of this now? Can you take guess? Same thing, F inverse of C I have बताया था. C is a subset of y. Now my C is singleton y, right? This is my C. Okay. So you understand the definition of F inverse of C. F inverse of C is that all the text such that f of x belongs to C. Yeah. Right. What is F inverse of C? Harshita, room number 9.
Yes, sir. Sir, x belongs to capital X such that f of x equal to y, small y.
Equal to y, correct. But why you not told f of x belongs to singleton y? I wrote it is belong to singleton y, right? Sorry,
Yes,
f of
sir.
x belong to C लिखा था. आपने इसको क्यों ऐसा change किया?
Sir, there is only one element, so I said.
Wonderful, wonderful. You solve the things, right? Is it all of you clear? Can you click yes if you clear with? Okay, good. Okay, nice. Okay, we are moving forward. But please remember that instead of saying singleton, we'll write y as a some abuse of notation. Okay, you can understand from that actually singleton. और एक bracket क्यों लगना है, right? So that is the understanding. Okay, with that understanding, this is all x belong to x such that. Okay, definition like so that f of x equal to y. All those this is what this set of pre-images of y, set of all pre-images of y. Okay. For example, to understand that one, you can take that example earlier, G3 and map to the months, January, February. What is the F inverse of January, right? Okay, just I am writing here with that thing. Today you can understand what is F inverse of January, right? That is set of students of G3, G3 who born on, so Reenu told very nicely, who born in the month of January, right? So set of students from G3, these are elements from the domain which are mapped to January. Students of G3 who born in the month of January, right? Yeah. Okay. Now, can you tell me?
Satya, can I ask one question?
Yes, please. Yes, please.
So my function is from G3 to natural numbers. I'm sending each person to their breakout room.
Yes.
Breakout room number. And those of us who don't have breakout room numbers, I'm sending them to 17. So it's a function. So those of you who are in the inverse image of 5, click yes. And those who are not in the inverse image of 5, click no. I'm going to repeat the function. The function is from G3 to natural numbers. Each person is sent to their breakout room number. And if you don't have a breakout room, you're sent to 17. If you are in the inverse image of 5, click yes. If you're not in the inverse image of 5, click no. You have 5 more seconds. You should ask yourself, what is your value? If you are in the inverse image of 5, click yes. If not, click no. Satya, I think except 1 or 2 people, most of them are okay.
Yeah.
Yeah, maybe you can take this up later.
Internet connection issue, maybe.
Yeah, you can.
Mandeep, what happened? Mandeep, okay. Yeah, okay. Yeah, good. You are all understood. Okay.
Okay, let me just make sure. Kunal.
Yeah.
All right.
Kunal.
Yes,
what
sir.
is your value?
Yes, sir.
What is your value?
I would be no, sir, because I'm not in breakout room 5.
No. So you never clicked no. What was the reason?
I clicked, sir. I guess it didn't work.
Okay.
Maybe
So
some network issue.
what is your value?
Mine is 8.
Very good. Okay. Yeah. Just making sure. Thank you. Yeah. Yes, Satya, please.
Yeah. Okay. So
Sir, I think Kamini has a doubt.
Yeah, Kamini, go ahead.
She put yes on.
Okay. Kamini, you have a doubt? Kamini, okay, go ahead. Yeah, okay, no problem. Then we'll move forward. Right.
So maybe the mentor can take care of it in the breakout.
Right. Yeah. Okay. Since, okay, in this example, okay, since I asked this question, so are you clear about what is F inverse of 1? Okay. F inverse of 2, right? Like that, what is F inverse of 9? Are you, so we have total 9 breakout rooms, right? Are you clear about? Do you want to comment on this? What are these? Is anyone want to comment on this? What is F inverse 1, F inverse 2 up to F inverse 9? Okay. Komalpreet?
Yes, sir.
Say,
F inverse
Hmm.
of 5 will be all the students of G3 which
Okay.
are in breakout room number 5.
Okay. So like that, all is, what is F inverse of 2? Okay, just one more time.
So
Can I ask one question?
all the students.
Komalpreet,
Yes.
will Utkarsh
Yes.
be in inverse image of 5?
What, sir?
Will Utkarsh also be in the
Yes.
inverse image?
No.
So,
No.
yes or no?
No. I think.
It depends on whether G5 is only or G3 is only students or you also involve mentors.
Yes, it depends upon G3 because
Yeah. So if your
earlier
mentors
we
are there,
considered.
then Utkarsh will also be in inverse image of 5. Is that clear?
Yes, sir.
Okay, thank you.
Okay, Komal, just one more question to you. These are what actually? What is F inverse of 1?
F inverse of 1 will be the students of G3
No,
which
that
are
is
in
okay. What is
breakout
this?
room.
What is this?
Set of pre-images.
Set, right? It is a set, right? Yeah, it is a set. So it is a set and it is a subset of which set?
Subset of G3.
G3. Okay. What about F inverse of 2? Subset of?
It's G3.
G3, right? All these are subsets of G3. Okay. Can you comment on something? How they are
Union
related?
of
Right. So F inverse of?
Satya, before you ask that, can I ask one more question? Sorry to interrupt again.
Right.
Yeah, not Komal, please, somebody else. I'm clearing all feedback. What is F inverse of 15? Remember, my codomain was natural numbers. I can ask you F inverse of anything. I'm asking what is F inverse of 15? Arpit?
So it is an empty set.
Say empty set. Okay, thank you. Yes, okay. Now I can.
Yeah. So, Sargun, now you can tell me what is that Komalprit is telling. If you is telling, then can you repeat that? Sargun. Hello, Sargun. Okay.
Yes.
Yeah.
Komalprit explains that what is F inverse 1 and F inverse 2, F inverse definition there. And these are the sets of which set, that is G3, subsets of which set.
Okay. Finally, she is saying something. What is that? Okay. Yeah. Is anyone want to comment? To continue what Komal is saying? Is anyone ready to continue that? She's telling about union, right? She's telling about something about union. Okay, Pujita, can you go ahead?
Yes, sir. Union of F inverse I to I is 1 to 9 is equal to G3.
Is equal to G3, right?
Yes.
Okay. Yeah, okay. So I hope all of you are clear. So I belongs to, here I belongs to 1, 2, 3 up to 9, right? Okay, also you can write I is equal to 1 to 9. F inverse of I is equal to G3, right? Yeah, okay. What else you can say, Pujita, about these sets? So she told that union is equal to whole of G3. Can you say much any other things you can say?
So all are the subsets of G3. This is what.
That is okay. Okay. These are all sets. These are all subsets of G3. Their union equal to G3. Still any other
They all
observation?
are disjoint.
Okay. So F inverse of 1 intersection F inverse of 2 is?
Empty set.
Empty set. So any two of them are disjoint or only few of them are disjoint?
Sir, any two of them are disjoint.
Okay. That means what they are called when they are
So mutually disjoint sets.
mutually disjoint sets. Right. Okay. So each of them, this 1 to 9, they are coming from which set?
So natural numbers.
Natural numbers, right? So they are coming from the codomain. Are you understanding?
Yes, sir.
So codomain से ले रहा हूँ and I am creating a subsets of X such that something is happening, right? Yeah. Okay. Now one question to all of you. Is it all of you clear what till now happened? Can you tick yes now? And we are clearing now. Just wait for clearing the feedback. Just wait for now you can tick. Is it clear what is happened in this example till now? Okay, good. If somebody can comment now, see someone want to comment in general. This is for example only, right? This is for this example. Is it somebody want to comment more general setup? We are clearing. Take time. I'll give 1 minute time also. It is not, I'll be hurry. Okay. If this comes from you, it will be very wonderful. Okay. That's why I'm just waiting. So this is an example. If you want, you can take more examples. January months also. This one also. Or if you want.
In the same example, maybe we can ask what happens if you take I equal to 1 to 10.
1 to 10. Yeah.
Just finally you want to say I belongs to N.
So in this example only you are saying?
Yeah, same example. Because codomain is natural numbers, right?
Yeah. Yeah. So what is F inverse 1 comma F inverse 2 like that F inverse 9 10, okay, F inverse 9 and F inverse 10. So these are sets, right? So what do you know about them? So what is it till now you told? Is it what you are saying? Sorry, I'm not. Okay.
No, whatever you're going towards, you want to say you want to use all the points in the codomain. Not just the range.
Yeah.
So you may want to increase the number of points on it.
Right. So Yeah, so you can see this, okay? 10 also, we are using one more element, 10 also, right? Not only 1 to 9, okay? You can take F inverse of 10 also. For example, if I collect these, what about their union? Okay, is it still continue that any two of them are mutually disjoint? Are they going to work? Okay, think about these things also. Then you can answer this, okay? Not only 10, okay, you can take 11, anything, right? We Sir asked F inverse of 15, right? Yeah. The reason why is are saying that here I discussed only up to 9. You can think of other things also. Yeah. Now can you comment? F is from X to Y. Whatever you want to say, you say. Okay, Sujit Kumar, you have some doubt?
Yes, sir. Sir, can we take set equal to F1, F inverse 1, F inverse 2, F inverse 3 dot 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 enter natural number.
Yes,
यूनियन इम्पटी सेट तो हम कह सकते हैं ये G3 का यूनियन होगा
Yeah, no,
सबसेट
no.
होगा
Yeah. No, no, wait. Yeah, I'm just writing whatever you're saying. Better go like that. Yeah, dot, like that. For every natural number, I'm correcting. Yeah, okay. What is
इसको
their
सेट
union? What is their union?
यूनियन यूनियन सर G3
G3 only. Still union is G3 only, even though we have infinite sets. Why it is G3 only? F inverse 9 तक कितना है union?
G3 सर
G3. F inverse 10 ये include करने के बाद भी G3 है.
हाँ सर क्योंकि F inverse 10 में इम्पटी सेट है
Empty set. F inverse 10, F inverse 11, they're all empty. Union does not affecting with that, right? Yeah, good.
Yes, sir.
Yeah, that's what.
सर मेरा क्वेश्चन ये सर मेरा क्वेश्चन ये सेट लिए है यूनियन इम्पटी सेट लेते हैं साइड से तो वो भी G3
Union empty set. Union empty set मतलब?
So he's saying if we take G3 union empty set, it is still G3.
Yes, sir. Yes, sir.
Yeah. Yeah. Okay. Okay. Yeah. So all of you, can you see now? Can you say something about this? F is X2Y. So since Sujit already discussed much better here, right? You take all of them also, their union does not matter, right? Yeah. Now can you comment? F in general, F from X to Y, what you want to say? Very less response. What happened?
Okay, maybe we can give them a hint by pointing out what Sujit said.
Okay.
This collection F inverse 1, F inverse 2, F inverse 9, and so on. He is taking F inverse of what? He is taking F inverse of all the natural numbers. So which can be written as the collection of all those points or collection of all those subsets, F inverse of n, where n belongs to n. And that's a hint.
That is for this example, right?
That
now
is for
we
this
are
example. Yeah. So that hint will maybe help them to see what you want.
Yeah. Correct. Yeah,
so
that's what.
What he said is can be rewritten as F inverse of n, where n belongs to n.
Yeah. So Harit Panwar, you want to say something?
Yes, sir. Sir, but if we take 10 in the codomain, then it won't be a bijective function. But in the definition, you told if we take the inverse, then we are telling that it is a bijective function. But
so I told you all. See, I told you very, very clearly. Please do not confuse and all, right? मैंने इतने बार बताया था. Okay, this does not be careful. Okay, notation confusion comes. This पूरा F inverse C पूरा मतलब entire thing is a matter. F inverse itself has no meaning. It does not have a meaning. ये पूरा मिलाकर मैंने define किया था. F inverse of C इतना लिखा है. Okay, are you following?
Okay, sir. Yes, sir.
Yeah, I know that there is a confusion, there is a problem. Okay, bad luck. That all I told you, right? Yeah. Okay. Now you want to say, Harit? You want to say something?
Yes, sir. So the union of F inverse I belongs to Y.
F inverse of I belongs to
Y.
Y.
Is equal to X.
X. Okay, this is one thing you are telling. Anything else you want to add for this?
Yes, sir. So the intersection of there would be mutually disjoint sets basically.
Disjoint sets. Okay. So how do I express that? Okay, let us take let R comma S belongs to Y. Yeah. Can you say something now?
If R is not equal to S.
Yeah, R is not very good. Yeah, R is not equal to S. Very good. Yeah.
F inverse of R intersection F inverse of S is an empty set.
Empty set. Good. See, all of you are clear what he said. He told 2 points, right? So that means can I construct something now? Family of sets. Can I construct? Is any one of you now? He told all of them. I am now asking question. Before coming to the functions, we done something, right? We may recall now, right? Anchal? Okay.
Yes, sir.
Yeah, you have something, you are getting some idea?
Family of sets we can create.
Family of sets, right. So family of sets lena hai. So here the family of sets are F inverse of R, right? Where R belongs to?
Capital Y.
Capital Y, right? So what is the index? This is the family. Okay. So each element, this is subset of what? Okay. Subset of what? And this is what? Generally this set is called, in the family of sets, this set is called? Indexing set, yes. Okay, this is indexing set. So indexing
yes.
set is what? And the set subsets we are constructing. These are subsets of which set? These are the questions,
Capital
right?
X.
Capital X, right? We are constructing family of subsets. Okay, and they are mutually disjoint. But we not yet proved. How do you prove that these are disjoint? Right? How do you prove that their union equal to X? These are the two questions, right? If you answer, then only it will be done. Is it all of you understand? Okay, we have two questions. Is any, be ready now, right? So be ready these two questions. So F is a map from X to Y, right? F is a map from X to Y. Okay, then we have two things. Given any Y in Y, right? We have F inverse of Y, right? So this is subset of X. We understood this, okay? Now, there is a chance that sometimes they can be empty sets also, that you understood, right? Yeah. So question number 1 is that how do you show, if you are assuming this is true, then how do you show this? F inverse of R is equal to total is equal to X itself, number 1. Okay. So R belongs to Y. Question number 2. If R is not equal to S, R comma S belongs to Y, F inverse of R intersection F inverse of S. Okay, why they are disjoint? If anyone want to comment, you can comment. So comment meaning you can make an attempt, okay? Then we will see whether it is going to happen or not. Nidhi Chadda, room number 8.
Yes, sir. So for that, for question number 1, we'll prove two things. First, that union of F inverse of R is subset of X, and X is again the subset of union of F inverse of R.
Yeah, correct.
So if we'll go first one way, then we'll take element from union of F inverse of R.
Yeah, correct.
And if let X, suppose X belongs the union of F inverse of R, then X belongs to any of F inverse of
There
1,
exists
2.
not any, there exists one R such that F inverse, yeah.
Yes.
Yeah. By definition, that is belong an element in X only, right? So this
Yes,
side is easy. This is subset is easy. Correct. Now we need to show that X is subset of that. How do you prove? Wonderful. That is correct. So now I take a small a belongs to X. How do you show that it is in one of them? That is important. Yeah. If you understand this, it is done. Yeah. Thanks for starting the things. So if I take I take an A in X, then there is some r in y, there is some r in y, says that. What is the meaning that, okay? What is the, so please write down those, okay? What is the meaning that some r in y says that A belongs to F inverse of R? Okay, you remember this definition one of you told. What do you mean by A belongs to F inverse of R? So there exists R such that A belongs to F inverse of R. What is the meaning of that? What do you mean by A belong to F inverse of R? Is anyone comment on that? What is F inverse of R? How we defined? F inverse of Y we defined, right? So you remember F inverse of Y we defined all those X as that F of X equal to Y. Now we are saying if I take small a belong to capital X, X is the domain, we are telling that there is an R such that A belong to F inverse of R. Okay. But what is this meaning and why they exist? These are the questions, right? Not tough. Not tough. If you are reviewing daily, then you can answer this very easily. Okay. I'm giving a little bit time here because this is very crucial. Okay, Komalpreet.
Yes, sir. A belongs to F inverse of R means there A belongs to X such
No,
that
no. What do you mean by A belong to F inverse of R? Iski answer batao. Yeah. What is the meaning
it
of
means
that?
that F of A is equals to R.
Yeah, F of A is equal to R. So what is that we are asking? If A belong to X, there exists an R belong to Y such that F of A equal to R. I'll repeat. Okay. Ask slowly, don't be hurry. So I take A belong to X. X is what? Domain. What you are saying? There is an R where in Y says that F of A equal to R. Is it happens or not happens? Given any element, right? I took an element, right? What is that we are asking? X is subset of this. So there is an R, right? So given any element in the domain, there is an R says that F of A equal to R. What is this? What is this? Unable to recall anything? Not Komal. I'm just in general asking. What is that? Given any element in the domain, there is a Y says that. There is an R says that this. What is that? Generally, I take Y. Now we took R. Now we are in confusion. That should not be right. Yeah. Ishika Goyal, room number 1. Ishika. Why
So,
this happened?
so this is the range.
Range and all. So,
So
what is this? Okay, now I'm going back. Is not happy. Is anyone want to comment? Okay, now unmute and comment.
So
Anyone?
you can say by the definition of function.
It is a
Definition of function.
Yes, it is a definition of function. It is simply the definition of the function. Okay, if you take an element in the domain, there is at least one R will be there. F of A mapped to, right? It is always be there. Okay, why intersection is empty? So this first one came from the definition of a function itself. How the second one will come? This comes from where? What do you mean by again? So intersection is empty, I want to show. Suppose it is non-empty. What is the meaning? What is the meaning that it is non-empty, right? Suppose, for example, so there is some Y belongs to F inverse of, some X belong to F inverse of R intersection F inverse of S. Okay. What is the meaning of that? What do you mean by that? Meaning intersection का meaning क्या है? पूछ लो आप. Okay. उसके बाद क्या? Okay. Yeah. Now anyone want to comment? Can you tick yes? Do not tell the answer now. This is easy actually. Okay, Sargun.
Sir, it means that X belongs to F inverse R and X belongs to F inverse S.
Okay. Yeah, problem क्या है, इसकी वजह से क्या होगा? Okay, yeah, go ahead, fast. Go ahead. What do you mean by x belong to F inverse R?
Since f is a function.
No, please do not tell all that, ma'am. So already here we discussed. She told clearly, what do you mean by A belong to F inverse of R? Meaning is that f of A equal to R. I'm accepting because today only this definition came, but I'm trying to help several times now. F inverse of Y is equal to all those x's that f of x equal to Y. What is the meaning that some Z belongs to F inverse of Y? Okay, this meaning is that that's why I gave some gap here. Okay, this meaning is that f of z is equal to y. Okay, that is the definition, right? If okay, then what is the meaning that z belongs to f inverse of y? F of z equal to y. What is f inverse of y? That of pre-images of y. Clearly लिखा था all those, right? आपको भी समझ में आ गया 5 का f inverse of 5 क्या है, right? f inverse of January क्या है? So please connect things. Yeah, what is f inverse of R then? X belong to f inverse of R meaning is what?
F of x is equal to R
R.
is equal
What
to
is that?
f of s.
F of x is equal to s. Then what is happening then? So x is in the domain, right? And it is y is these are in the codomain, right? Yeah.
Because
And we
f is a
started with
function and it
yeah,
can't
yes,
have
please.
the images. That the
Two images,
definition of
right? It is
function.
mapping two things. It is not true. But why we got a problem? Because I need to show their empty set, but if it is there, then there is a problem. That means this is true. It is empty is true. Both question 1 and question 2 answers are simply by definition of a function. Wonderful, right? Yeah, I'm clearing. Please think. So I'm clearing now this. Okay, all of you, please go through it. Take 30 seconds, then only respond. Both are coming from the definition of a function. This is one concept I learned from MTTS only. I'm very, very happy when I understood this concept. Really, really happy. First time when I noticed this. Because this is going to be useful for you later. You go to the group theory, cosets, everything comes from here. It looks very simple. You come across it several times. Subgroups, cosets, subspaces, they are also cosets. Everywhere you come across. Okay, sorry, I'll not speak. This is not easy also, okay, but even then try, okay. Because these are the pre-images I'm taking, because every element is mapped to somebody, right? So every element is in a pre-image of somebody. Function definition is every element has an image, right? That means every element is in the pre-image of somebody. F inverse of R is pre-images of some R. As R changes, I'm getting all the pre-images. That is entire X, right? Why intersection is empty? If X is in two pre-images, that means that X has two images. That's a contradiction, right? That's it. Very simple. By definition of function, both are common. Okay. Less response is not good, but please discuss in the discussion session, make it clear. Okay, I'm moving forward because we do not have time now. Okay, so can somebody say this? Okay, F inverse of given any y, given any y in y, given any small y in capital Y, right? F inverse of y, okay, cardinality. It is a set, right? It is subset of x, right? It is less than or equal to 1. Then what we can say about F? Can somebody want to comment on that? F inverse of y is pre-images of y, right? I take Y in the codomain. I'm looking the pre-images, right? Pre-image is either empty, no pre-image, less than or equal to 1 means what? Cardinality, right? Less than or equal to 1 means pre-image is equal to 1. Pre-image is only one element or no. Okay, what you can say about F in that case, right? For example, look at here, A, B, C, right? I have 1, 2. Okay, A mapped to 1, B mapped to 2. What is the pre-image of 1? A. What is the pre-image of 2? B. Okay, but yeah. Okay, I'll take more, 3 and 4, right? So what is the pre-image of 3C? What is the pre-image of 4? Nothing, empty set. So each element ka pre-image is either 1 or 0. So what do you understand from this set? Isa, we can draw and also ask, right? Easy. Okay. Nandini Gupta?
Yes, sir. The function is 1, 1.
Yeah. Okay. Yes. Okay. What about next question here? This is if, then, right? Natural question. What is a natural question? If this, then this. What is a natural question? Nandini, go ahead.
Is the converse true?
Converse true. If F is 1, 1, what about the cardinality of each element ka inverse pre-images? It is true, right? 1, 1 ka definition isse bhi aayega. Okay. What about the onto? From this can I get F inverse of Y? Somebody tell. I'm telling now F is onto here. Now you tell me this condition here. Is anyone want to comment? I'm clearing. Now tick if you want to do, right? I'm clearing feedback. I cleared. Now anyone want to comment? Harshita, go ahead.
Yes, sir. Sir, for all Y belongs to capital Y, cardinality of F inverse Y is greater than equal to 1.
Greater than or equal to 1. Good. Okay. Yeah. So if it is 1, 1, then this one. Okay. What happens if my function is bijective? F is bijective.
So
Yeah,
then the
Harshita,
cardinality will be 1.
exactly 1, right? So here 1, 1 ke liye bijective means 1, 1 as well as onto, correct? 1, 1 as well as onto. 1, 1 ke liye, so 1, 1 ke liye F inverse of Y cardinality less than or equal to 1 chahiye. Onto ke liye F inverse of Y greater than or equal to 1 chahiye, right? Then both. Bijective means both. That means that they have to be equal. Okay. Each element has one pre-images. Then I can talk about F inverse function from Y to X. Now only F inverse will come because each element has a unique pre-image, right? F is a function from X to Y, then F inverse is a function from Y to X, right? Yeah. Okay. One last question. Yeah. So here I will write. Okay. So here itself a small place I'll write and I'll stop with that. So otherwise I will teach more. Okay. F inverse is a map from X to R. Okay. So map is defined like this: X comma Y mapped to X minus Y. Okay. X minus Y. What is F inverse of 1? F inverse of 0 first. R2 to R. X comma Y mapped to X minus Y. What is F inverse of 0? Can you tell me which elements are mapped to 0? Be quick. Sonali Kumari.
0, 0.
0, 0. Is there any other things going?
Yeah, 1, 1.
Like that. Now tell me what is that pre-image. So which elements will map to 0?
0, 0. Means
0,
X,
0, 1, 1. Yeah, you
Yeah.
tell all of them. What is geometrically, what is that?
It's like a straight line.
Passing to
Passing
origin,
to
right? This,
origin.
right?
Yeah.
All these are mapped to this guy, right? Okay, X minus Y equal to, what is F inverse of 1, right? So line like this, right? All these are mapped to 1, okay, minus 1. Okay, these are all parallel lines. You see that their union is equal to entire R2. If I take any two of them, intersection is empty. You see that why I'm telling very careful here is that very beautiful concept. It will give it partition the R2 indexing with R. All things we done earlier now coming two concepts, right? In the sets we done something family of sets, and here mutually disjoint family of sets. All of them now you can get easily from the functions. That is the beauty. That's why I like this thing. Okay, I'll stop here just to explain the questions, and while you go to the room. So M2 of R to R, f of a equal to determinant of a. What is f inverse of 1? Okay, just what is f inverse of R? R is any real number that you need to discuss. What about the intersection of two things, R and S, right? When R is not equal to S, okay? So here R is not equal to S. One of you very nicely pointed out R not equal to S also you told. If they are equal, they are same, right? Yeah, he is very careful. Whoever told at that time, I forgot, but very nice. Is it F is on to? Okay, ask these questions. Is F is 1, ask these questions, right? Yeah, okay. M2 of R to M2 of R, F of A equal to A transpose. Is it a bijective map? Okay. N cross N to N, 2 power M minus 1 into 2 power N. Is it bijective, right? Is the questions clear, right? Yeah. N to E, natural numbers to even natural numbers. F of n equal to 2n. Is it a bijective map? Can you find map from E to n then? If it is a bijective, if it is, then can you think of E to n? If it is no need to worry about this question. Okay. G of n, natural numbers to odd natural numbers. If it is a bijective, then you see that even natural numbers are smaller set, but still there is a bijective map. Okay. So last definition with respect to that is that you have two sets, na? You have two sets A comma B are two sets. There are two concepts will be there, right? Like you see that this circle and this circle, these are similar but not congruent. Okay, congruent means if I put one over the other, they are same, right? Yeah, like that. If you have two sets, so equality, equal sets. Okay, other one is that equivalent. So they are equivalent. Equivalent meaning that their cardinalities are same. So two sets are equivalent, okay? So equivalent means their cardinalities are same, okay? Cardinalities are same, how do you prove? That, instead of cardinalities, we can say that there is a bijective map from A to B, okay? Equivalent means there is, so equal sets automatically bijective, right? So like congruent are all automatically similar, but similar does not mean congruent, like that here. So two sets are equivalent if there is a bijection. Okay, I'll stop here. Thank you.